Okay, so good afternoon, everyone, and you've been here for a long time. Uh, so finally, we have got our the next speaker, Dr. Samrat Goswami sir. Thank you very much sir, for coming. As usual, because start from its inception since 2018, sir is always with us. And I'll not say from 2018, it is only for TTTL that in 2018 it has been started. But since the inception of the department, if I say from 2008, sir is always with us, being it any program, being it any personal relationship or academic relationship, or maybe any research oriented kind of things, or anything sir is always with us. Sir, once again I thank you on behalf of Department of IT uh, to for accepting our invitation and to deliver an expert lecture on SPSS. As most of us might be aware of this, this is statistical package for social sciences. Uh, so I think he don't need any formal introduction, but he is Dr. Samrat Goswami sir, presently in the Department of Rural Studies of Tripura University. And rest of the thing you can, because the much I say would be lesser about him. So you can search it, you can search him in Google or in our Tripura University site also, you will find all his works. So before starting the session, I'd like to request our senior faculty, Dr. Sharup Nandi sir, to felicitate the speaker. Sir, please. Thank you, sir. And now the session is open to you, sir.
Good afternoon, respected teachers and participants. Okay, uh, I'm also a student of economics with some special interest on dynamic macroeconomics, environmental and resource economics partly, as well as some part of ecological economics, because, you know, all of us, we are now familiar with two words, climate change and global warming. So we have some keen interest on climate change related issues, global warming related issues, its impacts, water resources, water management, water scarcity, and all these things, which has broader impact at a global level, not particularly in local level. Incidentally, I always come in this department for this particular program to confuse the participants. And I'm here for the same job today only. Okay, so let us get confused about some type of statistical package which is known as SPSS, statistical package for social science, and particularly in case of regression analysis, how this package help us. Okay. Okay. So This is basics of SPSS, and we have quite a number of slides, but I will show you the slides. I will discuss a bit anything other than the slides. Okay, because that is important. So just remember and understand and think, if you are engaged in any kind of academic activity, be it masters, be it MPhil, be it PhD, the most important thing for you is to think. 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 If you learn papers, that means you are trying to get knowledge about some particular theory or some aspect or some concept through some other's perspective, viewpoint, right? So author's write-up means how the author has understood that particular concept, particular theory, particular situation, particular status. And then if you keep on reading different authors on the same topic, that means you are developing your ideas, concepts. That means you are developing your own perspective. So reading itself is not sufficient unless and until you are thinking properly. Read plus think. That gives you a result. Unless and until you are using this, by reading you cannot using it 100%. But if you read then think, then you can use it at least 60% to 70%. So thinking is important. Why I am telling about thinking in SPSS, I don't instruct you to think in terms of SPSS. But I tell you, I would like to inform you that if you think, then your life will become easier, because SPSS is a software, statistical, what is this? Statistical programming for social science, right? It will give you result. Whatever you put in SPSS, you will get some result. But that result, you yourself have to interpret. Unless and until you interpret that, this package will be of no use. Any package will be of no use. So knowing a particular package, for using it, applying it properly, again you have to think. You have to know and then think. Let it be a bit interactive. Do you think that life is moderated by only one variable, or you have a number of variables? If you think about any kind of a problem, in a real life problem, in your problem, is there any only single variable that is moderating your life, or there are more than one variable there? Think about any problem in your life, any problem. Is that problem can be addressed through only one variable, or more than one variable is required? When you come to the university, just at the starting point of your university journey for the day, you have to catch up a kind of a transport. Okay. When you got the transport, right in front of Badarghat, you have seen that police has stopped you. Second thing is that whether I'll be able to reach in the venue in time. Is there any traffic jam? Is there any other kind of condition? Okay, so in general, our life is a combination of different variables that plays an important role. And once we want to see that in our academic life, that whether two or more than two variables are associated or not, then we have one particular statistical process that is known as correlation. Whether two variables are related or not, that can be understood through the correlation, degree of association. When you make it a bit further, make it a bit more complex, then you might want to see that, okay, fine, I can understand there is a relationship, but I really want to know that whether there exists any cause-effect relationship or not. If you need to know a causal relationship between or among variables, then your correlation will not work. then you need something which is known as a regression. One dependent variable in a particular situation depends on number of independent variables, and that is usefully can be understood through regression analysis. Okay, so let's see what we have here. The general objective, I thought, to describe opening and closing SPSS, this is completely technical. To introduce the look and structure of SPSS, to introduce the data entry windows, data view and variable view, to outline the components necessary to define a variable, and regression using SPSS. So the initial thing is that you need data. Any kind of research depends on what? Information. And information in statistical term we call DATA, not data, but data. Okay. So if you have data, if you have relevant data, then you can think of to coming to a conclusion using certain methods, certain methodology, so that the objective you have decided, the kind of questions you have asked to yourself can be answered properly in an applicable and publishable way. Okay. Whatever research you do, unless and until you publish them in a standard journal, that will be of no use initially. Okay, so for publication, you have to have some applicable and publishable result. To get that result, you have to use certain platform. You have Excel, spreadsheet. You know very well that Excel can do a lot of work, but Excel cannot do some sophisticated works also. The regression that we are talking about, multiple regression you can perform in Excel also. That is possible. But if you want to do some kind of a canonical relationship, you want to perform certain, choice-based analysis, regression models, then Excel will not be able to perform. So in that case, you need some platform. You can use nowadays R is a free software. You can use that also, but you need to write some program for that. SPSS is a window-friendly, user-friendly kind of thing where it is already there. You have to enter the data. Either you have to enter the data directly or you have to import the data from Excel file, and then you can perform all sorts of analysis. Mostly the choice-based analysis, which you cannot perform in Excel kind of a format. Uses for SPSS is basically data management and then data analysis. Initially, you have to manage the data. If you manage the data properly, then you can think of analyzing the data. Now, if I say that statisticians used to collect data from the fields, the way they collect data, if that raw data they produce in that format only, that will be of no use. Once we speak, we communicate. How we communicate? In a meaningful manner. What is your name? We management is required. Unless and until you are doing some kind of data management, data analysis is not possible. Data management is a very, very important part. Let's see. Data management talks about defining variables, coding values, entering and editing data, creating new variables, recording variables, and selecting cases. It means that we all know that we have two types of data, quantitative data and qualitative data. What is quantitative data? That can be represented in terms of numerical figures, numbers. They are quantitative in nature. What is your age? I'm 24. I am not 24, but if you ask that, somebody will tell that, yes, I'm 24, 35, 50, 60, whatever it may be in terms of some numerical value. Are you married? 1. Doesn't make any sense. 99 doesn't make any sense. So either yes or no. Yes or no is not a number. So if it is not a number, what is your caste? Again, numerical values are of no use. What is your educational status? No numerical figures will be there to make a meaningful answer. So in that case, you are using certain words. Any kind of statistical software will not be able to recognize word as a word. Because if it can recognize the word, it will not be able to analyze it. So coding is required. You can convert your level of education in terms of years of school. So if I have completed Madhyamik or 10th level, then I am 10 years of schooling has been completed. 12 means 12 years of schooling has been completed. Graduation means 15 years of schooling has been completed. Post-graduation, 17 years of schooling. So you can convert in that way also. Instead of writing the status, you can write the years of schooling, numbers of years of schooling. Coding is also there. Entering and editing data that we will see gradually. What is data analysis? Univariate, bivariate, multivariate. Life goes with multivariate data analysis. Our real life goes with multivariate data analysis. I just say one thing, that we all in our own subject have learned about theories, right? In some way or other, any kind of theory. In social science, there are theories. In natural science, there are theories. But have you ever thought what is a theory? Any one of you? Have you ever thought what is a theory? Just sharing. Okay, you can answer. No problem. We know that Newton's third law is there, Newton's second law is there, law of thermodynamics is there, Gary Baker's theory is there, Adam Smith's theory is there, John Maynard Keynes's theory is there, Karl Marx's theory is there. What is theory? Hypothesis.
Hypothesis.
Theory is hypothesis, is a proven fact, collection of proven facts, collection of proven facts. Can we modify it a bit? Whenever we have seen any theory, before learning the theory, we always have learned about certain assumptions, right? On the basis of these assumptions, this theory has been made. What is assumption? Assumption is a framework. Framework that makes the most complex life into the simplest, most kind of a situation, within which you can understand the relationship of the variables in a fundamental and generalized manner. That is a theory. That is a theory. Okay. You make some assumption. Assumption means a framework. I can write on the, the wall also. But I will not write on the wall, I'll write here. Why? Because this has been given means you are assuming that this particular place is for writing. Wall is not for writing. So if I write, you can come here and can see and can understand also. Okay. Theory is a set of relationship among variables within a stipulated or suggested framework. That is the theory. Now, once you have a theory, then obviously that theory has variables, and our objective is to understand and go through the theory by making it as simple as possible through imposing certain assumptions. Once you have understood the theory along with the assumptions and started relaxing one and other assumptions, then your theory will be coming very close to a complex real life situation. Okay, why I am telling this? We have univariate statistics, bivariate statistics, and multivariate statistics. You have to understand univariate statistics and bivariate statistics so that you can perform well in multivariate statistics, because your real life is full of variables. There is no univariate bivariate situation. It is only a multivariate situation. When a problem crops up in any area, any country, any locality, problem has no particular fraternity. we from different fraternity has a tendency to look into the problem from our own, angle. If I am a student of economics, I would like to look into the problem from an economic angle. Somebody from political science try to look into the problem from a political angle. Somebody from sociology will try to look into the problem from social angle. So we have a kind of a fraternity, we have a kind of a tendency to look into that. Okay, but again, the real life deals with the multivariate statistics, so because multi-level variables are there. Straight, let's come to the opening. This I will skip because these, I think most of you know. Opening SPSS is icon on the desktop, or start program SPSS for Windows SPSS, and the following thing will appear. What will appear? This will appear. So open an existing data source. If you have an Excel file, you can open that existing data source. It will look like again a spreadsheet. The kind of a Excel sheet. This will open, and these are the cell edit field. So whatever variables you will write, this will come on this particular cell. These are the view tabs. View tabs means either you are looking into it in terms of a data view or in terms of a variable view. So your job is first with variable view, then it will come to the data view. Once you have done with the variable view, you have given the variable names and details about the variables along with the characters, the numbers, the decimal points if it is numeric. Then you come to the data view, it will look like this along with the variable names. And these are the cell information, what the cells are containing. This information you will get from this particular cell. Finally, you have a status bar or boxes here at the bottom right corner. In the data view, the rows represent cases or observations. Just imagine an Excel sheet. Each row belongs to one particular respondent. If you are collecting data from individuals, if you are collecting data from 100 individuals, the first row belongs to the first individual, the 100th row belongs to 100th individual. Okay, that means 100 data means 100 respondents means 100 rows, and each of the rows are basically capturing the variables against which you are trying to get the responses. Okay. Now, anyone can tell me that why we need so much data? You can ask the same question to one individual, and obviously you can get the reply from one individual, and you can do your job by asking the question to one individual only. But why we are asking so many people? To avoid error. What kind of error may come? Make yourself free. In this room, how many of us here? Around 50 of us here. 50 of us are having 50 different faces. That is a heterogeneity, right? Now, population is always heterogeneous in nature. That heterogeneity can be in terms of age, can be in terms of education, can be in terms of income, can be in terms of culture, cultural practice, habits. Okay. Why we collect data is because we need the responses about the same set of variables from different individuals. Okay. How many of you have seen Bahubali? By the way, Bahubali movie, देखा है ना सब? All of you. How was it? Good. Anyone else? Any other information about Bahubali? Don't worry, I will not tell the organizers. You can tell me. Prabhas was good. The heroines were also good. This kind of comments. Fight scenes were fantastic. Right? Ask this question to the students who have just completed their class 12 level. You will get a set of answers. Same question to the graduate students. You will get a different answer. Same question to the postgraduate students. Same question to us. Same question to the people who have just retired. You will get a different set of answers. That means the same question you are asking to different age group people will get you different reply, different responses. That means age differences gives you different responses for the same variable. Similarly, income-wise differences will be there. That means if you have a data which has accurately been collected from a heterogeneous population, you will get variation in data. That variation is important, and rows will capture those values either in terms of numbers or in terms of strings, right? Columns represent variables or characteristics of the subject of interest. For example, each column contains the answers to the questions on the treatment data collection from. If we have taken a data which is on health issues, so maybe a particular type of disease, prevalence of disease is related to age, gender, primary drug of use, etc. or not, that has been asked. One particular column that captures different responses for the same variable. One particular row captures same person's responses for different variables. Altogether, we have that data sheet, spreadsheets. The role of data editor, basically it comprises of two screens. One is data view, the other one is variable view. To move between the two, use the view tab at the bottom of the screen. You can directly click on that. It will appear. Otherwise, you can write this, click on Control plus T. It will again appear. Or view variables from the data view window. It can again appear. But the most important is that the first one is the easiest one. Just click on that, it will appear. See, this is variable view. The earlier one was a data view. This one is variable view. You have the name of the variable, type of the variable, width of the variable, decimals, labels, values, whether it is a missing variable or not, and whether it is a column, alignment, and the measures. These are the characteristics that is importantly you have to incorporate when you try to enter the data. Before entering the data, when you are defining a variable, all these things have to be incorporated there. This is a very easy part, this data entry process. Define your variables in the variable view, enter the data, the values of the variables in the data view. So first thing is define the variable, then enter the data in the variable view, data view. 10 characteristics are used to define a variable, which is type, width, decimals, label, missing values, columns, alignment, and measure. These you have already seen, I think, here. Okay, you have to fill all this up. Each variable must have a unique name of not more than 8 characters and starting with a letter, so that you can identify them. What we do generally, will you allow me to take this? On. That means if you give a port name of age, you can write age. If you have a large variable, then you can summarize it and give a port name for that also. Keep the name consistent across files. If you are doing with 2 or 3 separate files, then obviously the variable number and the name of the variable you have to maintain. Otherwise, there will be a kind of a mismatch, okay, between or among the files. What are the different types of variables? One is numeric, the other one is string, or you have a date. Output formats are comma, dot, scientific notations, dollar, custom currency, etc. These are the output. Numeric variables, numeric measures, codes, etc. Definition of the size of the variable has to be given. String, which is alphanumeric. String variables contain words or characters. Strings can include numbers, but taking here as characters, mathematical operations cannot be applied to them. You cannot put a mathematical operation as a variable. That is not accepted. The maximum size of a string variable is 255 characters, not more than that, because it has itself is having a size. Date, we know that month, day, and year-wise date has to be given. Computer stored dates and numbers from a base date. Generally, in SPSS, dates are stored as the number of seconds from 14th October 1582. Before that, if you are working on a big data, maybe if you are working on the climate-related data or data on kind of a temperature or rainfall, then you can reach up to 1582, but not prior to that. That is not required, I guess, because we generally, in case of climate change, IPCC and all, they are telling that the industrial revolution is the base. Earlier to that, that is not generally required. Create two variables. There should be an ID, the unique identifier, which will be alphanumeric with a maximum of 8 characters. Like age, the age of the respondent measured in years, a discrete variable ranging between 10 to 100. ID and age, these two has been created. They are numeric. Width is 8 characters, decimal is 2. Label has not been given. No value has been given because it is under process. And there is no missing values because there should be an ID. There should be a value against the age. There is not missing value there. Alignment is right scale. These are pretty technical in nature. I mean, there is another option of learning that. Learning by doing. Numeric you have to tick. You have to write the width as 8 and decimal as 2. Then you have to click here. Click on the string radio button and change the character to the size of the variable 8 in each of the cases. Numeric, it looks like this. Because age you are giving up to 100. That's why width. Descriptors for the variables, maximum of 255 characters, and this is used in the output also. How does it look like? It looks like this. Values labels are descriptors of the categories of a variable is coding. Now, if you have to define a missing value, you have to put a value which is unreal in nature. If you want to put that the age as a missing value, I'm telling just for example, you can put 999. 999 can never be a age, not even for a turtle, not even for a blue whale also. So in that way, if you want to put something which is for a missing value, you cannot keep it blank, then put 999. See, discrete missing value 999. Columns and aligns. Column sets the amount of space reserved to display the content of the variable in data view. Generally, the default value is adequate. Align sets whether the contents of the variable appear on the left, center, or right of the cell in data view. This is like Excel, I think, is very familiar to you. Numeric variables are right-hand justified by default, and string variables are left-hand justified by default. The defaults are generally adequate. This is the bit important. This is not only, important for the package itself, but for you also. When you are thinking about your objective, the second thing is you need to think about the methods which you want to deploy for examining your objective. Once the methods have been determined, then obviously the number of variables and the variable specifically has to be determined. Now, once the variables have been determined, then you have to think that the values against the variables you are going to collect the responses for, whether that is in nominal scale, ordinal scale, interval scale, or ratio scale. Because all the methods are not applicable against all the variables at all different scales. Okay, the kind of method you are going to use, particularly let's say it's a regression. If we want to use in regression, then what kind of regression model you are going to adopt? On the basis of that, you have to select a variable in a particular scale. Because in different types of regression methods, different types of scales are accepted. In some cases, nominal scale is accepted. In some cases, ordinal scale is accepted. Some cases, interval scale is accepted. In some cases, ratio scale is accepted. Whatever you do on the basis of the particular method. Generally, in SPSS, interval and ratios are designated together as a scale. The default for string variable is nominal. The default for numeric variable is also a scale. A little bit modification has come because this one, after this, 3 more versions have come. I don't know whether they have made any changes in the newer versions or not, but generally this is the case. See, the ID have been given and the age has been given. This is a data view. Earlier, you have seen the variable view. Now, this is the data view that you are seeing, and the values have been incorporated. ID, medical ID, drug, what kind of drug, age, and condition, relapsed or recovered. What is the condition? Either relapsed or recovered. That has been given. Now, saving is almost same as a kind of Excel file. The file must always be saved in order to save the work that has been done to the date. File save, move to the targeted directory, enter a file name and save. This is a very, very normal kind of a situation. This will look like this. Now, we have a very sketchy idea about SPSS. How does it look like? How to enter a data? You can enter a data, incorporate data, or import a data from Excel also. That is permissible. Now, how to use that data? Why we have taken regression? Because regression is an analysis which is much more down to earth compared to many other. Instead of univariate or bivariate cases, regression analysis a bit more complex and down to earth in nature. As I was saying, that real life situation involves complex relationship between or among variables. You can think about any kind of a situation. There is a war between Ukraine and Russia for 1000 days. That means for a prolonged period of time. If you want to analyze that, do you think that only 2 variables or 3 variables will work? Because many other underlying variables are there that might be giving a great amount of support or explanation between the warlike situation or simple situation. So there are a lot of variables involved in any kind of problem related to real life situation. The researcher in social science need to address these complex relationships using a structured model. So regression analysis or regression equation is basically a structured model. That model will explain the variables, the relationship between the variables, and will be able to give you some kind of estimation or prediction about the future. Just think that you have 100 students in your class, in your master's class. One student out of the 100 students couldn't be able to appear in the master's final examination due to illness. What happened in COVID? During COVID, in many of the institutions, whatever final result they got, on the basis of that, their first semester or first year's result has been determined. This is like that. Now, the controller section has been told that that particular student's result must come. How they will do that? Because the student has not appeared in the examination. The controller thought that one option is there. The option is that out of the 100 students, 99 students has appeared. So we have their graduation marks as well as their post-graduation marks. Let us see that whether the graduation marks as an independent variable can explain the marks the students have obtained in their post-graduation level. So your post-graduation marks is going to be a dependent variable and undergraduate or graduation marks is going to be an independent variable. The regression line always looks like y equal to a plus bx. A is an intercept term, b is a coefficient. And b actually tells that if there is a change in x by 1 unit, how much change in y will take place. That is the way, y equal to a plus bx. Now, when that kind of relationship has found out, that means this is known as an estimation. You are estimating the value of post-graduation marks on the basis of the values the students have obtained in their graduation exam. If you got that equation, then obviously that equation will help to estimate that particular boy's marks whose graduation mark is there, but post-graduation mark is not there. We have a marker. Let us just see two variables we have. One is marks obtained in master's MSc. The other one is marks obtained in BSc. Okay. So we are just assuming that we have a easy relationship. We are assuming that we have a linear relationship y equal to a plus bx. Now what data we have? We have 100 data on this. We have 99 data on this. We have 100 data on this. Now, out of the 100 data in X, we are omitting one data. That data is that student's data. So we have 99 data on MSc and we have 99 data on BSc. Using this, what are the 99 data? From 1 to 99 in your SPSS spreadsheet, right? Now, once you have this, then you have 99 data on Y, you have 99 data on X. You are actually going to get the values of A and B using least square methods. Using least square methods, you will get the value of A and B. Now, once you get the value of A and B, then this is a numerical figure, this will be a numerical figure. It might so happen that this will become y equal to 2.1 plus 0.3x. If you get the data of x for that student who is unable to appear in post-graduation or MSc, then with this data, you can find out his result also. Because he has not appeared in his MSc, he has appeared in his BSc. So from there, using this regression equations, very simple linear regression equation, you can calculate the value of y with that particular student's data result. Okay. Now, what type of data we have in a regression model? One is time series data, the other one is cross-section data, third one is pooled data, the fourth one is panel data. Time series data means, do you know anyone what is time series data? Time series data. Anyone? Have you heard about time series data? Stock price? Yes. One particular stock's price over time. That is a time series data. You want to know the agricultural production of Tripura for last 20 years. This is the time series data. Then what is cross-section data? Cross-section data means you want to compare all the northeastern states about their agricultural production in a particular year. Just to compare how they have performed in terms of agricultural production. All 8 states of Northeast. That is a cross-section data. One particular point of time, one time period, all the entities together. That's a cross-section data. Pooled data is a, if they so happen that in terms of time series also you have a small data set, in terms of cross-section also you have a small data set. You have 10 observations for 8 years. That means time-wise 8 is very less. Entity-wise 10 is very less. You cannot perform any kind of statistical application by using neither 10 observations nor 8 observations. So you pooled all of them. You want to know that whether in 10 years, one particular state in Northeast is doing well, or whether 8 Northeastern states in one particular year is doing well. If these two are separately insufficient, then take them together. 8 into 10 means you have 80 data points. That's a pooled data. You are pooling time series and cross-section together, it becomes a pooled data. Now, fourth one is the panel data. Panel data is a typical type of pooled data where you are asking the same question, repeating the same data for every cross-section observation and repeating them. Okay, see, a special type of pooled data in which same cross-sectional unit is surveyed over time. Same cross-sectional unit. You are repeating the values for the same cross-sectional unit. These are the different types. Okay, we have just talked about the purpose of multiple linear regression is to do predictions, explanations, and then theory building. Whether you can do any kind of theory building or not. In multiple linear regression, we can have a y pred. Pred means predicted value. Y pred, which is equal to a plus b1x1 plus b2x2 plus, if there are n number of variables, then bnxn. This is a one-to-one, one dependent variable, one independent variable. Now we have n type of independent variables, and we are assuming that y, change in y depends on each of the variables change. That is the job of actually regression. MLR estimates the relative importance of several hypothesized predictors. These are the predictors, x1, x2, x3, all these, they are the predictors. Here we have one dependent variable which is known as criterion, two or more independent variables, that are predictors or explanatory variables, which are, here we have n number of variables. Sample size is greater than or equal to 50, which is at least 10 times as many cases as independent variables. So cannot so happen that the number of variables you have taken, your sample size is less than that, it will never work. You have to have a larger sample size, 5 times or 6 times more than the number of variables that you have taken. Now, what are the variations in the model? How you will be able to understand? Take a simple example. You went to the market of purchasing vegetables. What will happen? When you go to the market for purchasing, daily vegetables or all, you have how much you will purchase. That depends on how much you have in your wallet right at that time. What you want to purchase at that time. What is the price of the commodities or vegetables that you want to purchase? Okay, so there are different variables. These variables, according to you, may, influence your amount of purchase of a vegetable basket. Okay, but there might be some other variables which you have not incorporated, but they are role. These are known as error terms, which you have not incorporated in the model. So the variation in your purchase, which is a variation in Y, it has two types of variability. One variability is predictable variation, the other is unpredictable variation. One variability is in your hand, which you can predict, that is predictable. The other is not in your hand. Whatever you have thought, it's beyond that, but they are playing their role. So your amount of purchase is to some extent influenced by that unpredictable part also, unpredictable variation. There are certain basic assumptions. Again, we come to the assumption, because without assumption, if you start creating a model, that will be, kind of a disaster. So we have to follow certain basic assumptions. One is independence. The data of any particular subject are independent of the data of all other subjects. Data must be independent. Cannot have dependent data, dependable to each other. Okay, there will be a problem of multicollinearity. Normality in the population, the data of the dependent variable are normally distributed. You know what is normal distribution? Anyone? Normal distribution of data?
Bell curve distribution.
K. Online.
Bell
Okay.
curve distribution.
Normal distribution is actually symmetric, right? So the best thing is start with the very basics. Whatever data you have, just draw a kind of a histogram and see that whether a kind of a symmetry is there or not. That means the middlemost values will be having maximum amount of frequencies, and gradually from either of the directions, the maximum values and minimum values will be having less frequency. We sometimes tell that a normal distribution looks like Mount Kilimanjaro or Mount Fuji. Okay, the top goes at the right in the middle, and on either of the sides, the values gradually, goes down. Okay, thank you. Then you have homoscedasticity. That is another assumption. It tells that in the population, the variances of the dependent variable for each of the possible combinations of the level of X variables are equal. Homoscedastics. That means whatever variances are there in the variable, the variances are equal. That gives you a homoscedasticity character. And linearity means in the population, the relation between the dependent variable and the independent variables is linear. If you study this in a little more, higher version, then you will see that linearity actually means that there should be a linearity between the variables, and there should be linearity among the parameters also. Then only your model will be considered as a linear model. This is a very basic difference between the simple regression and multiple regression. This is very easy. One dependent variable y predicted from one independent variable x, whereas one dependent variable y predicted from a set of independent variables. As we have said that if there are n number of variables, then you have n number of independent variables. One regression coefficient will be there. one dependent variable, one regression coefficient B. In case of that, in multiple variables, if there are n number of variables, then there are n number of coefficients, because each and every variable is impacting the dependent variable. So y is getting impacted by x1, y is getting impacted by x2, so on and so forth, and by xn also. So separately, the consecutive b value will tell that if x increases by 1 unit, then y increases by how much unit. If x1 increases by 1 unit, then how much y is increasing. That particular attached b, b1 or b2 or bn, that will tell that how much change is taking place in y due to 1 unit increase in x. R square. R square is the proportion of variation in the dependent variable y predicted from x. Capital R square for multiple regression is the proportion of variation in dependent variable y predictable by set of independent variables x's. Okay, I'll tell this later. This is a multiple linear regression equation. Y predicted equal to this. Means predicted 1 and 2 are the underscores. Y predicted is the dependent variable of the variable to be predicted. X is the independent or predicted variables. A is a raw score equation which includes a constant or y. That means if all the values of x's will be 0, then y might be having some result. Okay, due to the presence of the A. The B shows the relative contribution of their independent variable on the dependent variable when controlling for the effect of the other predictors. That means if y equal to a plus b1 x1 plus b2 x2 plus b3 x3, then this b1 is actually telling that how much x1 is affecting y. B2 is telling how much x2 is affecting y. B3 is telling how much x3 is affecting y. That means the change in y is partially due to the change in x1, which is understood in terms of the value of b and the sign also of b1. Same for b2 and same for b3. Partial changes, partial explanations, right? What variables are in the model? One approach is to perform a literature review and examine theories to identify potential predictors. You might be trying to prepare a model of your own. Shall you start by your own, or shall you take the help of certain similar type of literature where some model has already been stated? What you can do is that you can start with the already stated model, match with your situation, then you can go for rectifying the model. That okay, fine, in that situation, these are the variables that have been taken. In my situation, I am dropping one of the variables and incorporating an extra variable which is becoming important as per my assumption. Then we can see that whether the goodness of fit is actually helping it or not. This is sometimes referred to as the standard simultaneous regression equation model. A second approach is to examine statistics that shows the effects of each variable both within and out of the equation. Or you can simply see separately the correlation coefficient. If the correlation coefficient is giving adequate value, then you can incorporate in your regression model also. What are the MLR output? The following notions are essential for the understanding of MLR output, which is R square, adjusted R square, constant, beta coefficient, beta, F test, and T test. These are actually given by SPSS in terms of an output diagram or output window. For MLR R square, the coefficient of multiple determination is used rather than R, Pearson's correlation coefficient, to assess the strength of this more complex relationship. Why? Because this R square actually tells that whatever model you have prepared, a set of independent variables and one dependent variable, whether that model, whether those set of independent variables are adequately, explaining the variation in y variable or not. If the value of r square is very close to 1, that means the model that you have interpreted, you have prepared, is very correct model. If it is very close to 0 or less than 50%, that means there are other variables which are more affecting the y rather than the variables that you have incorporated. So you need to remodel that kind of equation. Adjusted R square and beta coefficient, the adjusted R square adjusts for the inflation caused by the number of variables in the equation. As the sample size increases, adjustment is less needed. That means in case of R square, there was a problem. The problem is that if you increase the sample size, the value of R square can be altered. But if you change the R square in terms of adjusted R square by making some modification, then it will not be affected in that way by the sample size. So if you increase the sample size, your R square may increase, but that adjusted R square will not be increased. So adjusted R square is always a better measure of the kind of model that you have prepared, whether the model has been, can be accepted or not. You can understand by taking the value of adjusted R square rather than taking the value of R square. B coefficient measures the amount of increase or decrease in the dependent variable for a 1 unit difference in the independent variable. That we have discussed, that if X increases by 1 unit, how much increase in Y will take place, that will be given by the value of B3 along with the sign. If it is positive, obviously there will be increase in Y. If it is negative, then there will be a decline in Y due to increase in X. Ideally, the independent variables are uncorrelated. That is also important, because if the independent variables are correlated to each other, there will be a problem of multicollinearity. One particular variable, that means sometimes it may so happen that you have taken wealth as one variable, income as another variable, the amount of land holding another variable. So there might be some kind of a correlation between any of these three, any two of these three. There can be a problem of multicollinearity. You are stating the same variable in some other format. Okay, that has to be avoided. Intercorrelation or collinearity, if the two independent variables are uncorrelated, we can uniquely partition the amount of variance in Y due to X1 and X2 bias can be avoided. Model building, this we have discussed already. Yeah. In regression, there are various types of regression models are available. Based on the type of research requirement, you have to prepare or construct your model. You can have an OLS type of model, simple linear regression model, where all the variables that you have taken are in terms of numerical figures. That's a standard regression equation. If you have a regression equation where your dependent variable is numerical in nature, but some of the independent variables are not numerical. Maybe you want to know that whether you have attended, maybe the income as a dependent variable, experience in years is an independent variable, whether attended a training or not is also an independent variable. Now, whether attended a training or not, you cannot define in terms of 1 or 2, yes or no. Okay, so in that case, you have to use a dummy. If yes, then 1, if no, then 0. Okay, so you have to put the value either 0 or 1 in all the respondents. Okay, so in that case, that type of model is also there. It may so happen that your dependent variable itself is non-numerical. So in that case, the standard multiple correlation, multiple regression models are not applicable. What will applicable? You have to go for a model which is known as a logic model. Logic probit or tobit type of model, where again you have to put a dummy for your dependent variable, and the independent variables can be dummy as well as numerical values will be there. There can be a stepwise regression where independent variables entered according to some order. One particular variable you can add in the second stage. Okay, that is a stepwise regression. By size or correlation with dependent variable, how you can choose one particular variable will be incorporated? That is in terms of either seeing the correlation with the dependent variable or in order of significance. Okay, you can incorporate stepwise. That is a stepwise regression. Hierarchical regression is there where the independent variables entered in stages, different stages. That's why it is known as a hierarchical regression. Now there are various significance tests are there, testing R square through F test, test of competing models like differences in R square through an F test or differences of R square, testing B, test of each partial regression coefficients by t test, see the t values, comparison of partial regression coefficients with each other, t test of the difference between standardized partial regression coefficients, beta values can be seen, whether the kind of values that you have obtained that is acceptable or not, that can be understood by the value either of t value or by the p value, probability value. Okay. The table will give you both the values. You can select in terms of taking either p value or the probability value. That's all about this t test and f test. R square we have discussed. Yeah. If you have a spreadsheet, go to data, analyze, then regression, then go for linear, analyze, regression, then linear. Then you will get this particular box where the left side, all these variables are there. So out of all these variables, see on the top, you have a dependent variable. So what is your dependent variable? You have to incorporate there in the dependent variable box. The selected independent variables you have to incorporate in the independent variable box. Then what you have to do? Then you go to the linear regression option, say, include constant in equation. Obviously, constant has to be included. Use a probability of f, and it has to be generally 5%, 0.5%. That means 95% confidence interval. And exclude case listwise. Cases listwise means the top has to be removed. This is the output. The top table shows the descriptive statistics. The bottom one, the second one is talking about the coefficients. So this is basically your regression equation given in a tabular format. See, the first one is a constant term. Second, third, fourth, fifth, sixth, seventh, all are the independent variables. These beta values are basically their coefficients, and the respective t values are there. The significance is there. See, all the significance we cannot accept unless and until the last one is acceptable, 0.023. Whenever we see the significance of a particular variable, we can see either in terms of 1%, 5%, or 10%. Above 10%, we generally do not accept. Okay, so if you have any value which is 0.1, above 0.1, you cannot tell that particular variable is significant. If it is less than 0.1, better 0.5 or less than 0.5, then 0.05 rather, then that is significant. That particular variable is significant. So it may so happen that in a particular case, your one particular independent variable is showing a result which is acceptable to you, but you see that the level of significance of that particular variable is not acceptable in terms of p value or in terms of level of significance. You cannot accept that result. Okay. This is the model summary. The value of R square is 0.143. What does it mean? 0.143 value of R square means whatever model you have constructed here, that model is in 14% cases, that model can explain the change in the predicted variable due to the change in the predictor variable. That means in out of 100 cases, in 14 cases, this particular type of model is in a position to explain the change in y due to the change in different x's. That means your model is not acceptable. Yes, there is a need to change the model. ANOVA is also telling that. Thank you so much. Okay, do we have any question? Do we have any question? Any or many, whatever it may be? No question. Yeah. Yeah, please. No question. No question. Very difficult to ask question in the last session also. Okay, thank you. If I have reached, my model has reached 5% to you also, then I'll be happy. But my suggestion is that learn it properly, apply it. Unless and until you will apply it, you will forget. This is such a type of thing. If you do not apply it, you will definitely forget. So apply it. When you will apply, then many things will come. Issues will come and you can solve that. And my department is Academic Building 1, first floor, on the right side. I am available any point of time when I am in Tripura. So you can ask me, you can go to me and can discuss. Thank you.
Yeah, thank you, sir. Thank you for this wonderful session. And of course, the last line has more importance. That yes, you are confused enough. Maybe as because you do not have any question. Anyway, thank you, sir, for accepting our invitation and for a nice presentation and this valuable talk. Hopefully, we'll sure help you with us in our future programs. Also. Thank you. And I think with your permission, we can call it a day. Okay. Thank you. Thank you. So again, we'll start at 11:30, but I'll request everyone to be present here by 11:15 at least in the next morning. Yeah, and the first session for the next day is going to be again one of the most important. As I have mentioned yesterday also, that how to prepare your manuscript if you do not want to use LaTeX, then how you can put citations, references, bibliographies, and all those things, and how to manage all those things if you are using a word processing or word processor. Okay, the first session for tomorrow will be in this particular topic. So we'll meet all of you then. Thank you. Thank you all.